Hi folks, we're going to take a look at this example of determining the altitude in a triangle. Okay, and we'll see that this is a significantly longer problem than the ones we've done before. Okay, but as you'll see, doing this problem will lead us to solving one of the more important problems in analytic geometry, which is very similar to this one. Okay, so first and foremost, let's get our bearings here. So we have this triangle with vertices A, B, and C. So as I did in the previous example, I'm not going to go crazy being accurate with my diagram because I just want to use it as a guide. Okay, so if I have this point A, -2, 4, my point B, well, let's see, -4, -3, so it's going to be further to the left, further down. So my point B is somewhere here, -4, -3, and then my point C, 8, 3, so further to the right and not quite as far up as this one here, because if I compare the Y values. Okay, and the idea is just to get something that's going to be a guide without having to rely on it being accurate. Okay, so here's my triangle. In fact, it's the same one as the last example, except in this one here, I'm looking for the altitude that starts from point A. The way we define the altitude is it's the line segment that goes from a vertex to the opposite side, except it doesn't necessarily go to the midpoint of the opposite side. It has to hit the opposite side at a right angle. Okay? So, what I'm looking for is the length of this line segment. Now, if you recall in the previous example, we were again looking for the length of the line segment, but it was easy to determine the other point on that segment. Excuse me, because it just happened to be the midpoint between the other two vertices. Here, a little more work is needed because I'm going to have to first find this point here. But what I want you to keep in mind is that this point is just the point of intersection between the segment BC and this altitude that we're looking for. And that's how we're going to determine this point, as a point of intersection. But hey, if we're finding the point of intersection, it means we're going to have to solve a system of equations. So we're going to see here how we can use our previous knowledge to solve this. So the first thing I need is, if I want to find the point of intersection, I'm going to have to find the equations of these two lines. Okay, so let's start by finding the slope of BC, because I know I need a slope and a point to find the equation. So the slope of BC, okay, is going to be y2 minus y1 over x2 minus x1, so 3 minus -3. Remember, the order has to be kept here, and 8 minus -4. So if I started with point C to begin with, I have to then start with point C in the denominator also. So what do we have here? This is going to become 3 plus 3 is 6 over 8 plus 4 is 12. So our slope is going to be 1/2. Okay, so now I can use either one of these points to find the equation of the line. I'll stick with this one here, even though it's got the 8, at least everything's positive. Okay, so I know my equation is going to look like y equals mx plus b. I'm going to stick in my point, which is a y value of 3. My slope is 1/2, and the x value is 8. Okay, and this works out quite nicely because 1/2 of 8 is equal to 4. And so I solve for b, subtract 4 to the other side is -1. So the equation of BC is y equals, what was my slope? 1/2 x minus 1. Okay, so not too bad. Let's now move on to finding the equation of this perpendicular line. So since this altitude has to be perpendicular to BC, it means that the slope is just going to be perpendicular to the one we found. So what's the negative reciprocal of 1/2? It's just going to be -2. Okay, now while I only have one point on this line here, the vertex A, that's all I need. So let's stick this point and the slope into y equals mx plus b. So y is equal to 4. Okay, m is -2. Our x value there is -2 plus b. So we have 4 equals, this is going to be 4 plus b. And when I solve for b, 4 minus 4 is 0. So the equation of this altitude is y equals negative 2x. Okay, so what I'm looking for now is the point of intersection between these two lines. So it's just a system of equations. Okay, so here I'm going to choose to do this by substitution. Normally I use elimination, but since the y's are both isolated, okay, I'm just going to replace this y by 1/2 x minus 1. Okay, so that's how I'm going to solve this system of equations. Okay, so I'm going to substitute this y here by 1/2 x minus 1, which is equal to this y there. Okay, so let's see what we get. We get 1/2 x minus 1 equals negative 2x. And I have a linear equation to solve, so I can find x. And I'm going to do that by eliminating this denominator. So I'm going to multiply both sides by 2. Okay, so 2 times 1/2 is just 1, so I'm just left with x here. 2 times negative 1 is minus 2. And here 2 times negative 2x is just negative 4x. Okay, so I'll bring the negative 4x to the other side, becomes x plus 4x, 5x, equals, bring the negative to the other side, positive, and so x is just equal to 2 over 5. Okay, and now to find the y value, I can just plug it into either one of these equations. I'm going to use this one here. It looks a lot easier. So y equals negative 2 times x, which is 2 over 5, okay, which is negative 4 over 5. Okay, and so now I have this point of intersection is equal to 2 over 5, which is 0.4, and negative 4 over 5, which is negative 0.8. And now I can finally end this problem by finding the distance between these 2 points. Okay, so the altitude is just given by the distance between those 2 points. So that's going to be the square root of, okay, x2 minus x1, so it'll be negative 2 minus 0.4 squared plus y2 minus y1, so 4 minus negative 0.8 all squared. And let's simplify this. So square root of negative 2 minus 0.4 is negative 2.4 squared plus 4 minus negative 0.8 is 4 plus 0.8, so 4.8 squared. Okay, and I think at this point I'm going to use my calculator to simplify that. Okay, calculate that for me. So we have negative 2.4 squared plus 4.8 squared is equal to 28.8. So we have the square root of 28.8. Okay. And since we're not given what the units are on this Cartesian plane, I'm just going to say root 28.8 units. Okay. Now, if this was some sort of application problem where it was representing the length of the road, then I would approximate this. But since this is just a pure math problem, I'm going to leave it in exact form. Okay, so we see that this is a significantly longer question, and we will notice that some of these analytic geometry questions are going to be quite long. So step one was to realize that in order to find the altitude, we needed to find this point where the altitude and the base of the triangle intersect. So we found the equation of each of these lines, and then from there we solved the system of equations to find the point of intersection. Once we found this point of intersection, we were then able to determine the length using our distance formula. Okay, that's it for this one.